designed a database schema in your life? Okay, about a third. How many of you have heard of NoSQL? Okay, so just to give you a bit of where I should go, right? Okay, so a little bit about Tengen. It's the company I work for. I've been working with them for about 5 months. They started a new database project. They started a new database project because they found that the technology they were using at that moment was not scalable. It was just too little that would support a lot of data being written really fast as part of DoubleClick. So Tengen owns the product MongoDB and owns all the developers as well in such a way that they control the product, which means that they have all the knowledge to support other people using the product. So that is basically what we're doing. We help other people use our product. The product itself, MongoDB, is open source. You can download it from our website for free and use it for free. If you want help, we can help you with it. We give you support, consultancy, and trainings, and anything you can think of, really. We have offices here in London, about 10 in London, but also New York, where our headquarters is, and in Palo Alto and in Dublin. Our last round of funding was about 31 million, which happened about last year, with our main investors being Sequoia, Flybirds, and Union Square. The only one I know quite a bit about is Sequoia, but I don't have enough time to talk about it. So let's continue. So MongoDB is open source. It's high performance. It is meant to be very easy to use to start with, but also very easy to scale up to large installations. But the largest being, as far as I remember, 1,400 machines being used by Disney in different setups, but they use quite a lot of machines. It is meant to give you the possibility to start small and then grow large with very little, with you having very little to do it except for adding new machines. It also makes it very easy to use in a cloud environment. You can just spin up a new machine, start a new Mongo instance, tell the other machines that it's there, and it will start using that and replicate data to it. It's quite popular, getting more popular as well. We have about 100,000 downloads a month. One of the language drivers, the one that I'm developing, gets about 13,000 downloads a month. So there's lots and lots of people using MongoDB. So the main benefits of MongoDB are agility. It's the ability to store complex data in a very simple way, which means it's schemaless. I have a slide for that, so I'll show you what it is in a bit. And it's also very easy to scale. And because of this, it makes it very cost effective. Now, a little bit to show where MongoDB lays when you look at database, well, database in general. On your bottom right, you have relational databases such as Oracle and PostgreSQL and MS SQL Server and things like this. And on the top left, you have Memcache, where Memcache is a very simple interface where you have a key, and each key can have a value. So you can store data with a key, and you can retrieve data with a key. It's very simple, which makes it really, really fast. On the other side, you have a relational database such as, let me pick Oracle here, which has a lot of very good functionality, but it tends to be quite a bit slower than things like Memcache because it has so much more functionality. So with MongoDB, what we try to do is make it very easy to use, still have a lot of functionality, but we won't get where relational databases are because of architectural decisions. But also still very easy to scale and very easy to make use of. Now, I'm getting a little bit more technical now. The data that you store in MongoDB would be in a document. If you're familiar with normal database, you would store data in rows in your tables. In MongoDB, you store documents, and a document is sort of equivalent to a row, except that it can be very rich data. It can't, besides having just key values, you can have keys with arrays and things like that. Documents you store in a collection. A collection is basically a number of documents that you can store. And a document is not like a Word document, it's like what we call it's field value combinations. We can set indexes. Indexes help you speed up lookups very, very good. if you're familiar with relational database, if you have multiple collections or tables in this case. If you want to join them together, you can do that with joins. In MongoDB, there's no such thing as a join between collections, but you can have embedded documents, which means you have a document, and in that document, you have embedded other documents. So the documents in MongoDB are schemaless, and what that means is that even though you have a collection with documents in it, the documents in there don't have to have the same format. They can be different. It is very useful if you're, for example, aggregating lots of product catalogs. Like Amazon has books as well as computer parts and even shelves and things like that, right? And you can imagine that a book doesn't have the property that a computer part has, like the CPU speed or the computer speed is not an attribute of a book. Now in MongoDB, you can put all of those products with distinct or different fields still in the same collection, and you can do meaningful queries on them. It makes it very useful if you have to read in lots of data from other places. But it's also very useful if you're developing an application and you realize that halfway through, like, oh, we want an extra field. In MongoDB, that is a trivial thing. You just start storing documents with a new field, or if you want to change them, you can change them as well, of course. So it's really flexible and really good for prototyping applications. So I have a very simple document here with 3 fields. It has an ID, it has my Twitter handle and my name. That's a very basic document. A slightly more complex document you have here, you have 3 fields, it's ID and my name. And then you have a field called bookmarks. And the bookmarks, instead of being a simple value, it is actually an array. It's an array of objects even. So in this one document, there's actually three documents. There's the big one. And there's this one, which has the title and a URL. And this one has another title and URL. And those are called embedded documents. And querying this, you can do on the normal fields, but also on the embedded fields very easily. And you can add and change them and put indexes in them as well. Even a little bit more technical, I'm sure I'll get back out of that in a bit. If you want to have a blog where you want to store a blog with names and URLs, each blog has blog entries. Blog entries have comments. Blog entries can have tags, and they're written by users and comments as well. In order to model this in a relational database, you need 5 tables to do this properly, because in a relational database, there's only one proper way of storing your data. Whereas in MongoDB, there is no single solution to storing your data. It all depends on how you're inserting data, what sort of data you have, how do you want to query it, and how do you want to update data. So one of the examples that you have that you can store the same data in is in 2 collections. You have a blog collection where each document is a full blog. In there you have an array of all the blog entries, and in these blog entries you can then store the comments. And this is all perfectly possible. The only limitation you have here is that each document can't be more than 16 megabytes, which sounds like a little, but it's absolutely perfectly fine. My whole personal website, all the entries in there, easily fit in one document. So but how you design your schema is depending on how you want to use the data in it. A few of the other functionalities in MongoDB that set it apart from some of the other document storage engines. It has secondary indexes, meaning that you can have more than an index than just on a specific key, which is by default the ID field. You can also have it on any other field that you have, or combinations of fields. There's functionality for geospatial or 2D indexes, meaning that if I want to store all the pubs in London, then MongoDB has functionality finding, give me the 50 closest pubs to the current point, being a geospatial index. GridFS is useful for storing large files, saying you have a video file of 400 megabytes. Obviously they don't fit in a document because a document can only fit 16 megabytes, right? But GridFS is a layer that allows you to then automatically split up this large file into smaller chunks, which makes it very useful if you have, for example, a video player. In video players, you can often seek to like the middle, which means that if you want to get the video files out of MongoDB, you don't have to read the first half, but you can skip to the correct point because the GridFS solution will chop up your video or any file into specific chunk sizes. MapReduce is a way of accessing, doing some data. MapReduce is very difficult. especially if you're not familiar with it, and even if you're familiar with it, it's really difficult to debug. So MongoDB also has an aggregation framework, and an aggregation framework allows you to get a lot of data, do queries on what you can do, averages or sums and things like that in a very easy way if you come from the relational database backend, whereas some of the other NoSQL solutions, document storage engines, they will not provide this kind of functionality. They are a lot more difficult to use. So MongoDB is built for easy to use and easy to scale. I'll skip this one because... Okay, so I'll skip to replication. So I mentioned that MongoDB is very easy to scale, and by default you can use it with just one node. A node being an instance where you have MongoDB running with your data set. Now, you can imagine that if you have one machine, if it breaks, you can't access your database, which is not a good thing, especially not if you're trying to make money. So what MongoDB allows you to do is set up multiple machines that talk to each other in a replicating way. So we have a primary here, the slightly greener green, and two secondaries, which are database instances that have all the data that the primary node have, but you don't write to. So you only write to the primary node, but you can read from all the three nodes. Meaning that if one of the machines goes down, the other two can easily take over, and no data is lost. What you can then do with the machine is you can repurpose it or start up another cloud instance of a server, and when that comes back up, you get to MongoDB itself will move the data back to the old primary node. So what replication gives you is scalability and failover. If one of them fails, not a problem. Just one of the other nodes will take over. It also gives you read scalability. Like instead of reading from one node, you get to read from multiple nodes, which makes, as you can see, well, you get less traffic to one node. Is that a question? Yeah.
Write scalability. Do you have one node for writing? Or?
I'll get to that in a second. So the second slide is sharding. So where replication helps you with read scaling, if you get to a certain amount of data, because replication will want to have all the data in one specific node. If your data set gets too large, it doesn't fit on the machine anymore, and then you need to have another solution, which is sharding. Sharding allows you to separate your data set on a specific key. In this case, let's pick name as your sharding key. And sharding allows you to split up your whole data set depending on that key. So when you would now write something, each document needs to have the sharding key, and if it fits in the first range, it will write it to the first replica set. If it fits in the second one, it will write it to that. So if you have even multiple clients on there, each of them will only write through a third of your data set, giving you the right scalability. This is a very complicated, so that most of you won't ever have to use this, or actually hopefully you will have to use it at some point if you're using MongoDB, which means because you have so much data traffic going through your system that yeah, you're being really successful, right? And then this is awesome. All right, that's about this. A little bit about, sorry, I see 2 questions. Can I take those at the end? Is that okay? Okay, so a little bit about MongoDB's community itself. Before I started at 10gen, I visited MongoSV in Silicon Valley. 1,100 people visiting a conference about MongoDB. It's amazing. I learned so much there. A really good vibe there. All over the world, there's about 23 of them. There's one in London, which happens on June 20th. I have a slide of that. I think it's the next one. Amazing ways to learn about MongoDB. It's also really good to see what other people are doing with the technology. There's also lots of MongoDB user groups. If you have questions, you can always end up there as well. And looking at London and the UK itself, there is MongoDB UK, which is an annual conference dedicated to MongoDB. It's on June 20th. Tickets are $50, without VAT, I suppose. We're expecting about 600 people wanting to learn about Mongo. There's, I think, 18 talks or something like that. So that's a really good place to learn lots. If you want to just have a quick overview, we have a MongoDB user group meeting every last Tuesday of the month. It was last Tuesday. So the next one will be May 29th. I think we'll have it at the new Google campus here in London. So might be a good reason to go and watch the Google campus as well. And for very small things, if you have questions if you're using MongoDB in production, if you want to have 2 hours of free consulting, every 2 hours we have office hours, which is somewhere near Old Street. Drop in, say hi. It's in a cafe. They have amazing cake. It's always important, especially because you're just coming out of the office at that time. Where you can ask questions if you have anything there. Feel free to drop by. That's about what I have to say. There are a few questions. I'll start with you.
I have two questions. Firstly, when you've got your 60 megabyte file limit, is that for each layer or does each, like say for example, can you have